right, guys, so let's get into applications with quadratic functions. So we now know how to solve quadratic functions. We've got a few different ways. We can use the quadratic formula, we can solve by factoring, and we can solve using the square root method. But we got to know the why behind it. So we know how to find those key characteristics of a vertex, of y-intercept and x-intercepts. But let's learn how to utilize those in everyday life. So by the end of today's lesson, you're going to be able to solve the question, why would we want to know how to solve quadratic functions? So you're going to see some key characteristics that line up with words throughout these word problems. So if you ever hear initial height, initial value, or anything that says initial, I want you guys to automatically think, so your brain should go to, okay, I need to be looking at standard form because I need that y-intercept. So remember, you want to be in standard form for this. Now, it says, when does it hit the ground, or how long does it take to land? So if I'm looking for when, so I'm looking for a time, correct? So notice that this is a time. But it's how long. So it's seeing where does it end. So this is an ending point. These are going to be your x-intercepts. And remember, we learned how to solve for these x-intercepts in 11.1, 11.2, and 11.3. That's, you can use quadratic formula, square root method, factoring. All of these will get us to x-intercepts. So it really doesn't matter which form you're in, as long as you're comfortable solving for those x-intercepts. And then the last one is maximum or minimum. And it says, how long does it take to reach a max min point? So anytime you see a max or min, your brain should automatically go to vertex. So we're going to find all of these different values, and we're going to start off with our y-intercepts because it's easiest to start at your initial value. So example 1 says, Ryan throws a tennis ball from his apartment balcony. The motion of the tennis ball can be described by the equation h of t equals negative 2t plus 4t plus 48, where t is the time in seconds and the height is represented in feet. So what is the initial height of the tennis ball? So I need to know, first off, where am I at? Like, what am I trying to look at? And then from there, I can go into trying to figure out where I'm actually starting. So I need to figure out what I'm looking for. So if I'm looking for an initial height, go back to those key characteristics, and I need to find the y-intercept. So I'm going to say that the y-intercept of the equation represents the initial height. Therefore, the initial height, I'm going to go to my equation. It's already in standard form, so I really just have to look for the C value. So the initial height is 48 feet. And guys, we can draw a sketch of this. So just imagine that we have an apartment building, and here's Ryan's balcony, and he's going to throw a tennis ball. So he's got his tennis ball in his hand, and we're trying to figure out how far that tennis ball is from the ground. So off the ground, we've got 48 feet. Because eventually, he's going to throw that tennis ball, and it's going to hit the ground. All right, you guys are going to try the next one in just a second. So you're going to see where Amanda tosses a coin from her window into the fountain. But before you try this one, let's go to the next page, and we're going to look at example 2 where Morgan's going to launch a rocket, okay? So we've got to do a little bit more for this one because it's given to us in factored form, and we've got to go from factored to standard form, okay? So it says Morgan launches a rocket from the top of a hill next to the lake. The motion of the rocket can be described by the equation h of t equals negative 2 times t minus 5 times t plus 3, where t is the time in seconds and the height is represented in feet. We need to know the initial height of the rocket. So we can go ahead and sketch this. So I know she's on a hill next to the lake. So we've got a hill, and we've got a lake here. It can be whichever lake you want. Lake Lanier is kind of gross, but I mean, you do you. And Morgan is going to be launching a rocket from the top of this hill. But we don't know how tall this hill is. I know eventually the rocket is going to launch, it will explode, and all the pieces will eventually land at the lake level, which is going to be ground zero. But I've got to figure out how far this rocket is from the ground. So this is our unknown. Well, in order to do that, I've got to go ahead and convert from factored form to standard form. And remember, we can use the box method, but we've got an initial value of 2, so we will have to distribute that. So first thing I'm going to do, sorry about that, guys, is I'm going to multiply t minus 5 times t plus 3. And that's going to give me t squared minus 5t, 3t, and negative 15. So I'm multiplying the components. I can then add like terms, and that'll give me my h of t is equal to negative 2 multiplied by t squared. Negative 5t plus 3t is going to give me negative 2t minus 15. Next step is going to be to distribute the negative 2, which will bring me to my standard form of h of t equals negative 2t squared plus 4t plus 30. And we can now finish our word problem. So it says the y-intercept, because we're dealing with initial height of the equation, represents the initial height. And that is what this equation asked us for. Therefore, the initial height of the rocket is 30 feet. All right, here's what I want you guys to do. I want you to work on the U-try from the first page, and I want you to work on the second U-try, and we will go over them in the next video.